time to kill, I was going to offer I could do a quick description of our trees again, maybe
Okay.
5 minutes. I
Sure.
felt like I kind of cheated Mark out of Callahan out of the conversation he wanted to have there, and I realized I needed to have a better way to explain it, and I do now.
Alrighty.
I
So
did
we're
that
live.
for the webinar.
We're
Mark
live now. Let
Callahan.
me.
Who's Mark Callahan?
I'm gonna let this one nurture
Oh,
that.
that is something you learn really, really.
Sorry, yeah, Tim. I mean,
Thanks, Matt.
sorry.
I wasn't sure if you were talking about Mark Leith or Tim Callahan at the time. So.
Sorry,
Anyway.
Tim. I'm so used to saying Mark.
We are live. This is DB Hangops, August 21st, 2014. It's 11 o'clock Pacific. And today we're going to be talking about GTIDs and MariaDB. Jerry's got a demo prepared for us. And if we have some more time, you just heard Matt mention it, so maybe a little more stuff on R trees, some stuff on shared storage, and even index fragmentation if there's time. But beyond that, I guess we can get started. So I'm Jeff. I'm a DBA at Box. And let's do a quick round of introductions. Why don't we start with Daniel?
Hi, I'm Daniel. I'm a DBA at Snow.
Okay, Jerry. Jerry's mic is muted.
I'm sorry. I'm Jerry Narvaja. I'm Senior Sales Engineer at SkySQL and co-host of the RSQL podcast.
Okay, Mark.
Hey, I'm a development manager with MySQL at Oracle.
Okay, and Matt.
I'm Matt Lord, obviously, and I'm a product manager in the MySQL group at Oracle.
Okay, Robert.
I'm Robert Cooley. I'm a database administrator at Eventbrite.
Okay, and Tim.
And I'm going to turn my camera back off. Sorry.
Hi, I'm Tim Callahan from TokuTech.
Alrighty. Cool.
Not
so
Mark.
now that we know we have Tim Callahan and not Mark Callahan, I'd say go ahead and take it away, Jerry. If you want your screen shared, I can lock the camera onto you, and you can do your thing with GTIDs.
Okay, here we go. So hopefully now all of you are seeing, and I need my little cliff note here. So what I have set up here is 3 servers that are named. I'm not sure whether the file name, the host name is actually visible here. It's Bart03, which is a master. Bart04, that is playing the role of a standby master, and it's set up in master-master replication with Bart03. And down here, there is another one called Bart05, which is a slave, and it is replicating from Bart03, which is the active master. So just, oh no. Of course, as soon as, okay, let's see. Oh, the keyword is not working. On one of them. So here we have a show master status for Bart04 and Bart05. Bart03 is hung. Don't you love when these things happen?
So Jerry, real quick, do you have to hit Control Q? Just out of curiosity.
No. It's dead.
It was worth a shot.
Well, let's try Control Q again. And Control C. No, it's not even responding to Control C. Oh, there we go.
There it goes.
So show master status here. This is the main master. And here we're going to do the show slave status. And you can see the IP address of the master and the regular coordinates, and it's fully replicating. Let's do it the other way around. Show master status here on this, and then pager S and show slave status here. And you can see it is replicating from the Bart04 from the standby master and the regular coordinates here. So nothing new up to this point. So let's say that I want to change and start using GTIDs. The first interesting thing here, and I'm going to get out of this for a moment, is that GTIDs in MariaDB 10 are enabled by default. This means that if I go to the where the binary log files are, and they should be here, and I do MySQL bin log MariaDB bin 001, what we will see here in this point is that although I'm not using GTIDs in any form or shape, the GTID is still registered automatically here. And this is what we see. So besides having the regular coordinates for replication, it also identifies a specific coordinate with the current GTIDs. So what this means is that, use my test, that I can start setting up the GTID variables, and all the variables are dynamic. So if I do show global variables like GTID, what I will see is that it is already getting some variables that were there from my previous tests. They just reset all to basic coordinates. The GTA domain ID is one of the differences with a regular MySQL. It has 3 components. The first one is a domain ID. The second one is the server ID, and the server ID is the same server ID that you would use on regular MySQL replication instead of using UUIDs. And the third number is the transaction number, if you wish, which is a sequential number which increases with each transaction, and it's sort of a transaction counter. GT domain ID is not only a global variable, but it's also a session variable, and I'll talk to that towards the end of the presentation. So the thing is, I want to switch this slave, which is currently, I'm going to do pager less and show slave status. As you can see, again, it's replicating, and if I go to the bottom of show slave status, it's telling me that it's not using GTIDs. So what I'm going to try to do now is make this slave to start replicating using GTIDs instead of, and to do that, what I have to do is first find out what are the corresponding GTID coordinates for the show master status. So let's go back here, show master status. So what GTID do these coordinates or these positions correspond to? And to do that, there is a function that it's called binlog GTID pos, where I just use this 667, and that's what I get. I get these two. So on my slave, the first thing I have to do is stop the slave. Of course, you have to make sure that at this point the slave is caught up if you're going to do it on a live system. I have to do set global GTID slave position equals, since it's replicating from this master, it doesn't matter, I can start with this one. It will eventually register the correct one as it starts replicating. And then I do change master to, and in this case, since it's already a live server that it's replicating in a healthy way using regular positions, there's only one variable I have to change, which is master use GTID equals slave position. Now I start the slave again, do a show slave status, and it still keeps reading from the same coordinates as before. Everything is running, and the difference is that down here, now it's using GTIDs, and these are the coordinates. As you can see, I just used one position from the slave, from the master it is replicating from, but now it picked up the information in the binary log, and the information in the binary log also had this coordinates there. So now this server is already using GTIDs. Any questions this far?
I have a quick question, Jerry. So when you've enabled GTIDs kind of dynamically like this, so let's say you have a very high throughput system, lots of transactions coming through, and your slave is caught up, to the point at which point when you stop it, is it possible that you could grab the GTID position from some position in the past or on the master, plug that into the slave, and it'll know to like skip over them correctly to the right point to start replicating up again?
Well, you have to give it a position that you know. So probably one of the things that you could do is, in this case, I have a master set up. So if you have a very high throughput system, I would start by using a slave off the passive master if I were in a real operational situation. And the reason for that is I can stop replication on the passive master, in this case in here, and take the position of the coordinates here, which wouldn't be advancing because I stopped while the active master is receiving coordinates. And then I would use those to set it up, and that way I can guarantee that I know exactly where I'm stopping and starting. The other way to do it is, let's add a transaction here. So insert into T1. T1 is a very simple table. Values, and I'm going to say row 10. So I don't really know. I should have stopped it before. Hold on. Select star from T1. So I don't really know what GTID corresponds, but let's say I do a show slave status here. This coordinate here corresponds to where I stop the slave if I stop the slave. So what I can do is do select binlog GTID auth and use this information from the slave, which is where the slave stopped. And comma. And it would give me the right. I'm sorry, there is garbage day. Hold on. Okay. And it will give me the right position here. So that's another way. If you have a live system, you stop the slave, and that way it will keep replicating from the position it already was in. If I use this function on the wrong server, for example, on the passive master, what I'll get, well, now it actually knows where it is, but let's see if I can use it here. Oh, again, froze. Basically the point is, if you use coordinates that are non-existent on the wrong server, it will come with a null or an empty string response. So in this case, since it's master-master, both are actually going in sync. But this one shouldn't be going in sync. Yeah.
So that was actually a very good example that you gave there, Joey, where you can grab the information off of your slave, get the master host that your slave is replicating from, and just issue the statement up there to get the GTID coordinates. So that's pretty solid. And now, is this kind of syntax specifically? Is this binlog GTID POS function specific to MariaDB, or is that also in MySQL?
No. This is specific to MariaDB. So what I was trying to do is, there we go. So since this is not a master, it's not advancing the master status coordinates in sync with the other two servers. And so this position doesn't correspond to a valid, existing GTID on this server, and that's why I get the null. And that's once you get the coordinates from the slave or from the master, but in this case we got them from the slave, so we know that it's a known position to where the slave is in sync. We have to find the GTID by logging into the corresponding master. So the trick with this GTIDs is domain IDs, and let me speak a little bit about domain IDs. As you know, MariaDB has group commits, and group commits allows to do parallel replication, and basically all the transactions that have been committed to disk or fsync to disk on the same as part of the same group commit, they're synced. They're applied on the slave in parallel at the same time, and this is whether they're on the same schema or different schema. When you have domain IDs, the slave already knows that transactions coming from different domains should be able to be applied in parallel. So when you have an HA system, and like the one I'm trying to simulate here, which is a very common setup, you have a passive master, you can set up both masters to run with the same domain IDs. And what that means is you're applying all the transactions to one master, and the other one is just standing by. And then all the transactions, it knows they correspond to the same application. One of the things I used to do as a DBA is when we had schema updates, we would basically stop replication from the active master to the standby master, apply the alter table, which had to be backward compatible with the current application, on the standby master. And so if it takes them a little bit longer, it didn't matter. And in this case, what we would do is, with domain IDs, we can change the session for the alter table to be different than the active domain ID. And that way, it's a way to identify that it's something that it's more of a maintenance task. And depending on the application and the context, it can be done in parallel with some other statements on the slave. And then, you do the traditional, once the alter table is finished, you switch traffic to the standby master that will be running with a new schema after enabling replication again and letting it catch up with all the pending transactions that happened during the alter table. But that is a one-way, changing the domain ID for the session will be one way to signal that it's, something that can be done somewhat in parallel. It will identify, of course, that there's no conflicts, and do maintenance tasks like that. The other way to do it is, I used to have a monitoring application that would be collecting status variables, and put it onto a different schema on the same database. And if you don't want that replication to interfere with regular application replication, the session for the monitoring application would have a domain ID that is different than the main domain ID. That's another way where you can say, oh, okay, the thread that is it is stuck for whatever reason might be the one that corresponds to a different domain ID, so you can skip those transactions on the binary logs because they're not important as long as you're skipping on the secondary, on the monitoring application domain ID. If you have master-master where both are active, something that I know it will make many of you cringe, you can have both masters with different domain IDs. So you can get very creative on how you deal with this. Another thing, caveat here, is that server ID is also dynamic, which may or may not have good uses, but it is something I recommend people to try out and see if it works on their environments. But changing the server IDs is certainly something that I consider slightly dangerous.
So Jerry, something I just wanted to pop in and ask a question about real quick. Mark had actually mentioned this in the chat, that in Oracle MySQL there's a master auto position. Is that a variable, Mark, or a
no, it's actually the change master command. So it's in the change master command itself.
Gotcha. And so yeah, you would set that, and that allows MySQL to automatically determine what statements it needs to execute from the binary log without having to set a specific coordinate or something. Is there something like that in Maria, or is this like the method you just showed kind of the prescribed method in Maria?
No, there is something similar to that. I used the variable. Let me find it here. Oh, the GTID slave position. There's 3 values to the GTID slave position. One means, okay, it's not using GTIDs. The other one is using slave position, actually this one here. And there is another one that it's current position. And if I do show global variables like GTID, some of these variables, there is a current position that it sort of works like that, but I would have to research that. But yeah, I think there is something equivalent, but it doesn't quite work the same way.
Isn't the current position just start replicating from where the master is?
Well, the current position is actually picked up from the binary logs, not from the slave. But you say, oh, if it needs to skip transaction IDs, you know what? I don't know the answer to that. I would imagine that there is something similar, but I would have to look it up. I can look it up and get back to you guys.
Okay.
So one thing I think that is worth describing, Jerry, is what is the point to GTIDs? I'm sure plenty of us, I'm sure most of us know the answer, right? But a lot of people watch this.
Yeah. For the most common uses, I'm going to stop sharing because this was the point. If I go into multi-master replication, it will take a little bit longer. What I consider the most common use case is when let's say you bring a new slave into the mix. A common strategy I would use also as a DBA is I would make it first replicate off the last slave because it was easy to do a MySQL dump from that slave and put it in there, let it catch up, and then you have to promote it to replicate from one of the other masters. And that can, with regular positions, you have to be very careful and stop replication or, get some valid coordinates and then promote the slave, one level up if you wish, to coordinate from another master. And that takes some work. If you have GTIDs, basically you stop the master, you change the host, and it will start replicating from the new host, and since it knows with GTIDs exactly what transactions have been applied or which ones have not been applied, it can continue replication without having to bother about whether the binary log positions are the ones that you need or not. So that's what I consider the most common applicable situation or use case for GTIDs. In MariaDB, you also have the possibility to have multi-master replication. So this server that I called BART05 could potentially be configured, and this can be a second demo further along the run, on a future session of DB Hangops, I could make it replicate from both masters. So GTIDs will be the way to for the server to know that a given transaction that came through what we call replication streams directly from the 03 master, and as it receives it through the 04 master, it knows that a transaction has been already applied and move on with other transactions. Those will be the two main use cases.
GTIDs.
Gotta love them.
Confusing yet amazing.
Yeah, exactly. So, Mark, I have a question for you, if you don't mind. Maybe you can answer, maybe you can't. I believe, or at least I heard through the grapevine, that GTIDs and MySQL 5.7 might be slightly different than 5.6.
GTIDs themselves, no. I mean, well, there's work going on to not require actually restarting the slave or restarting the instance itself, because that's one of the problems that we've had. GTIDs themselves, the concept of GTIDs and how they're implemented and replicate and those kind of things, they're pretty much the same. It's more around general admin management tasks, making it easier for the admin to turn it on, and those kind of things. So it's just building on top of what's there already.
Yeah, that's what I heard, and I wanted just to make sure that I heard right.
Yeah, essentially being able to increase parallelism to make the turning it on and off dynamic in the running server, and then increasing visibility, like performance schema tables to check on all the related status and stuff like that. Definitely
looking forward to that.
It was requested a lot, and we listened. We knew we had to do that kind of stuff.
Yeah, I think
all the instrumentation into all of the different threads and all of that kind of thing as well was a big thing, and that's coming along. It was done in 5.7.4. There's more work in 5.7.5. There'll be more work in 5.7.6. It's just ongoing. There's a lot of stuff going on with it.
Sounds really good. Yeah, because for us, I mean, we're getting ready. I mean, we're finally rolling out our 5.6 upgrade more broadly, and are validating it. And we really want to start turning on some of these new tunables. And GTIDs is like one of the really hot ones because it opens the doors for so many other applications we can do just on the engineering side, building our own things that consume the replication stream and not having to effectively build in our own GTIDs. And so having genuinely global unique statements we can trust. But because with and so it sounds like 5.7 later releases are bringing in some of this finally, but I mean, I think for us, we're actually getting ready potentially to use Tungsten Replicator to get around this kind of having to stop everything to move it all around. But
yeah, one more because of the change in the bin log format, you can set up MariaDB to be a slave of MySQL server. But once you move to MariaDB 10, you cannot set up a MySQL server to be a slave of MariaDB. That is because of the additional information with the GTIDs on every single transaction, whether you use them or not.
It's worth saying the whole drop-in replacement thing disappears, right, with 10?
Well, in a way, I've been dropped the drop-in replacement from my vocabulary a long time ago. I don't think 5.6 is a drop-in replacement for 5.5 either, but you have to run MySQL update and you have to run a number of things, and once you move in one direction, whether it's not a drop-in replacement anymore.
So out of curiosity, Gary, what version were you just demoing with, by the way?
10.0.
Gotcha. Okay.
Which is GA. So let's do a select version here. It's 10.0.12. I think that we are on 10.0.13.
Okay, thank you.
Shame on me.
So, I mean, yeah.
From Gavin as well, actually, Jeff, the 5.6 upgrade, it looked like he was using the stuff that I did on the load average, replication load average.
Oh, yeah, he rolled out a monitor for that thing. It is absolutely stunning because we actually did saturate a replication pipeline about a month or two ago on one of our clusters. And we're like, what the hell do we do? How do we know the capacity of this? Because, you know, we could run sysbench and get an arbitrary thing, but it's very different than the workload we run. And yeah, so he took a lot of the PS helper stuff that he put together and was able to put together a T collector so we could feed that into our OpenTSDB monitoring system. Absolutely amazing. I'm actually, if he hasn't published a blog or open sourced about it yet, I'll give him a little nudge about it today.
You wrote a blog about it. I saw a graph that he put on there. So I mean, if that's working well for you guys, it's...
Yeah, I will throw a link to that. Thanks for reminding me.
Okay, that was all about GTIDs. MariaDB.
So I guess, yeah, just wanted to kind of open it up. Questions from anybody, comments about GTIDs, anything, because they're in Maria, they're in MySQL 5, 6, and above. You know, questions, comments. We've got good people to answer it here.
Thanks, Jerry, for that run through. The one thing that came to my mind is just worth mentioning. I think another kind of a nice another nice feature to go along with GTIDs on the MySQL side is, so with Galera or Tungsten, like you're talking about, you have those options for. Let me close this. Making a bunch of noise. That's the sound it makes when somebody's trying to talk to me. So you have Galera and Tungsten for synchronous replication, but of course that has downsides on write-through performance. But another option is, which is interesting moving forward, is GTIDs with by themselves with semi-synchronous replication, which is a newer feature in MySQL as well. So then you have, you're not doing synchronous writes to disk, but you're doing to the tables rather, but synchronous writes to the relay log, and then so it doesn't have nearly the same overhead as far as writes go. So that's an interesting one, and that combined with Fabric is another. The three of those put together is another interesting one moving forward too.
Yeah, the Tungsten has its own implementation of GTIDs, and Giuseppe had blogs a long time ago about comparing their GTID implementation versus 5.6. And one of the things we have been talking with the codership guys is how the Galera GTIDs play along with the MariaDB GTIDs, and in theory, with Galera, you can get into some really interesting topologies as well, and because you can have slaves that are replicating from all the nodes in Galera, for example, and basically Galera has to transport the MariaDB GTIDs to make sure that those slaves know exactly where the transaction originated, and creates also some interesting use cases. I don't think that the ecosystem fully understands GTIDs, and I remember when I started working at MySQL was when replication was really, really young, and people started doing really creative stuff, and that's how the server IDs actually came into being. Is people were starting to use circular replication without the server IDs, and they got into these endless loops of replication, and then that's when server ID got introduced, and to avoid that, I expect something similar to start happening with the current state of the art. We're very early in the GTID maturity.
I guess that's one of the questions I had, Jerry. We went with a UUID, right? What was the decision? What made you guys go with the server ID itself? Do you know the answer to that?
No, that's a question I have myself.
I mean, it's a problem in even the most basic replication setups, right? A lot of people get that wrong, where they don't set up the server IDs uniquely across all of the different systems, and replication starts flapping and all of those kind of things. Less error prone to actually use a UUID anyway.
Yeah, and the same goes for the fact that you can change server IDs at the session level.
Yeah, that's scary shit, right? I mean,
yeah. So I don't know what the thinking behind the design. I'm sure there is a reason, and I'm sure that if we put all the heads together, they can rationalize it. But I don't know. There's advantages and disadvantages, to having it done that way.
Yep.
I think my internet's getting a little shoddy right now, and everyone's starting to pick up on my end.
Yeah, you're getting a little flaky. Everybody else seems fine though.
It's indeed a bit flaky here and there.
Geoffrey, I know you directed your question to Tim, but what I would say with grip commit and the possibility of parallelizing transactions, if you're replicating into a TokuDB slave, the question is, oh well, no, things are. I'd also love to hear some of your take on GTIDs with Maria MySQL. I know the replication system is separate from the engine, but does it have any impact on TokuDB? So that was the question directed to Tim, and I'd love to hear Tim's position. But because of the fact that the slave can ingest some transactions in parallel, I would say that with a higher ingestion rate that TokuDB is capable of, it would make slaves not fall that far behind on highly transactional or high traffic systems. I don't know if Tim actually ran any tests with that or having multiple masters.
I haven't tested it specifically, but Jerry, as you said, I think the replication is above the engine, so I don't think these differences between Maria or MySQL. I think what you get with GTID, we're just going to take advantage of, but not necessarily do anything specifically different, given that our engine is different than InnoDB. I mean, I still share the question that I think Mark was kind enough to ask earlier, where I still don't have enough operational experience with MySQL to understand the impact that GTIDs are bringing to these servers, other than hearing Jeff say that it opens up a world of potentially new development opportunities for his team.
Well, I think the easiest way to think about it for me is okay, I guess I'll go for sorry. The easiest way to think about it is, before you were just replicating a position, so you had no other context about an event. It was just, I'm reading this event from this file on this position, and that's it from this master. But now you've got, so everyone has kind of a unique identifier. So every replication event has a identifier to identify the host where it originally executed. So in MySQL, it's the UUID. It sounds like in Maria, it's the server ID. So 1, 2, 3, 4, 5, 6 versus a UUID. But so it has that unique identifier for this is where the replication event originated, and it's the 25th statement that we've received, or that was replicated or logged, I should say, on that particular machine. So it allows you to, so it makes things like more complex replication topologies much easier to manage, because okay, this is from this particular host, and this is the 50th event from that particular host. So you don't have, so you can deal with 50 different replication instances, and you're not going to end up executing the statement 5 different times, because you're just blindly reading in things from a file, and you don't know where it came from, what the order was, and so on.
Does it do anything then specifically with respect to crash safetiness on slaves or masters?
Well, I think not really. I think that's where I was mentioning the semi-synchronous. It's kind of a nice partner feature to GTID. So the combination of those you can use to implement kind of a very cheap and easy HA solution. So you've got the slave, that before you commit on the master, the slave has it in its local relay log, and so that you can then fail over to the slave and you can say, hey, and there are also commands that you can say, hey, hold off until we get to this particular, this particular point.
Yeah,
so
in MariaDB, some of this position information is persisted on InnoDB tables. So if the slave crashes and comes back up, doesn't have to rely on the master info file information.
That came from InnoDB and 5.6. All of that from 5.6, basically. So, Tim, the thing that I think illustrates it the best, right, is like Matt said, there's a file name and a position of a bin log where something is, for instance. And the particular problem is when you're trying to rebalance a slave to be a new master and then rebalance the rest of the slaves to point to that new master. And the ultimate problem is most replication systems aren't set up in one go, right? So in the ideal world, if you set up every single system in the replication hierarchy at the same point in time, then they may very well have the same master or log file and position across them. But in the real world, what happens is, systems get restarted, so they get new binary logs and new positions, or new systems get put into the overall hierarchy at some different point in time, and they get newer binary logs and positions. And then when you try and rebalance all of that, you don't have that one particular ID to start from across the entire hierarchy, right? In the old way, there's this big mishmash of different binary log numbers and different positions within those binary logs and all of that kind of thing. So if you've got a fair-sized replication hierarchy and you try and rebalance all of that, you then have to go into every one of them, do this big manual, it's just a mess, right? There are systems that were written for it, like MHA, MySQL high availability is what that's called, which kind of get it right, but it should have been easier, and that's essentially what GTIDs are. They're a unique identifier for the transaction that's been executed across every single system in the hierarchy. So no matter where you rebalance from whatever system, every single system has got that unique identifier that you can start from. So you basically say, hey, I'm at position X, whatever it might be with the GTID, and it goes off to the new master and says, okay, start me from position X, wherever that might be in the binary logs. And that's really the essentials of global transaction IDs.
Yeah,
okay. That makes good sense, but the one question that brings up in my mind that I would ask Jerry is the MySQL implementation seems pretty clean in that using a UUID is going to guarantee uniqueness. What Jerry showed us was this short little number that I'm wondering how that could possibly be derived and yet unique in such a compact form.
The technique I was using as a DBA was I would use, I think the function is called inet to number or something like that in MySQL, and convert the IP addresses into server IDs. For demo versions, that is extremely complicated and a number that says mostly nothing. But you can certainly use that to guarantee uniqueness, since in a given network, Mark Leith actually posted the name of the function is inet_n2a, and then you can get unique server IDs.
Okay.
Or A2N. Yeah.
All right.
Yeah, so I'm not sure if Maria, I'm assuming Maria does something similar, but in MySQL, so each replication node keeps track of essentially everything that's executed, and that's kind of how the auto positioning works too. So it'll say it has this executed set, so it says I've every node in the replication group, of course, has this unique identifier. So it says, okay, I've executed transactions 1 through 20 from this server, 1 through 1,000 from this server, and so on and so on. And so that's how it can keep track of. It can do the auto positioning, and also, if you change the topology, it knows what it's executed and what it hasn't, and it will execute obviously everything it hasn't yet replicated. I'm assuming I haven't really looked at the MariaDB implementation, but I'm assuming it does something similar.
Yeah, when it comes to actual functionality, at the end, both the solutions are trying to address the same problem, right?
Right.
Cool. Okay, so any other questions on GTIDs, or should we spend a couple minutes talking about something else?
You seem good now, just FYI. Your audio and video.
Yeah, it looks like everything finally recovered. I guess something happened with my Wi-Fi here. Okay, so I guess I just want to open it up real quick. Do you guys want to talk about shared storage, or is that something we should hold on to for something else? Or Matt, did you want to talk about some of the archery stuff a little bit more today for like the last 10 minutes maybe?
It's up to you guys. We can talk about NFS for 15 minutes or something if you want, or shared storage in generally. I could talk about that, or I could do the little recap of archeries, kind of more detailed. It's up to you guys.
Quick show of hands.
I vote for archeries. NFS can take us a whole half an hour.
Yeah, we could do a more detailed one. I was just going to say for NFS, I think NFS v4 and then v4.1 has really addressed a lot of the historical issues with it on the MySQL side. Because NFS v4 now has mandatory and advisory locking, so it's not just the total weak consistency model. So you can before MySQL would crash, and it hands out an exclusive lock and says, okay, tell me when you're done with it. And if you don't ever, when you crash, obviously you're not able to tell it, hey, I'm done with it. So then MySQL would restart, and it wouldn't be able to get that exclusive lock on the InnoDB system tablespace files. So that's addressed in NFS4, and then 4.1 addresses the performance problem. So it has PNFS, or parallel NFS, and that's actually supported in Red Hat 7 now. So those are the two main things, obviously performance and locking. But if you're willing to go a bit more towards the bleeding edge, you can use NFS v4.1 to address both of those major issues. So then NAS and SAN should be relatively close performance-wise if you're using PNFS. But that's all I had to say. I just wanted to throw that out there. And then I can do the archery one if you want, or we can continue that discussion.
Yeah, I don't want to go into a rabbit hole with NFS, but let me try my stab at it. Yeah, NFS 4 was a great improvement, and it works. One of the things I don't understand is why, when you use regular NFS on a Linux volume on a remote machine, even NFS 4, which is what I tested, you still have some slowdowns and serious issues and locking issues. While when you use the drivers for a SAN or anything like that, that still is NFS 4, things seem to work a lot better.
I'm not sure. I don't have much practical experience with it, thankfully. I know I've certainly had my share of problems with NFS in the past, but I know that and I don't know what it uses by default as far as the locking goes, but I just know that with v4, it supports mandatory and advisory locking. So I don't know what it does by default, but you can get it to essentially behave like a normal, Unix file system. So your flock and fcontrol calls will behave as you would expect from a local file system, because it keeps context as well. So if you're a local file system, you got a lock and your process goes away, it releases that lock. And I don't know the details, but supposedly it keeps additional context as well, so that when the process goes away, you don't end up with those stale locks. I haven't actually worked with it though, so your usage may vary. That's just the general description of it.
Daniel actually made a comment on the chat window. I don't know if you want to talk about it, Daniel.
Yeah, that's about the binlog impossible mode. And I recently had a situation where the bin logs of a server was on NFS, and the NFS server just went away for a few seconds, and MySQL just tried to write the bin log files. It wasn't possible to do that, and then it just continued without writing the bin logs, which is quite a disaster if you're using replication. Now in 5.6.20, it's possible to configure what MySQL D should do when it can't write the binlog files. So it's really great.
Yeah, and if I remember right, that originated from you, the original bug report. I don't remember for sure, but yeah. So by default, we just leave it the way it was because we didn't want to change that behavior in a GA release. But yeah, in general, I would definitely agree that most people would want to say, binlog impossible mode equals whatever the number is, I forget, for just not continuing when you can't write to it.
It's like a port, isn't it, or something like that? It's an enum.
Yeah, you can say ignore error or abort server. Ignore underscore error or abort underscore server. So abort underscore server is what I imagine most people actually want, but we left it at the default, which was so you had the previous behavior.
Yeah.
And I mean, just outside of that, that's just another of the NFS problems, right? Is random network errors or flaky networks between your database server and where your data lives, right? I mean, that's something you want to try and avoid as much as possible. And the other thing that we've seen a lot is performance issues and trying to debug the performance issues, because you have no idea what else is using the NFS storage as well. There could be any number of hosts, any number of processes that are actually affecting it that are just completely unrelated to your database server that's affected at that point in time. And it is nigh on impossible unless you can hop on the NFS server or know what else is trying to use the NFS server and to actually debug that. It takes generally more people than you, the DBA, to actually figure that out, because the storage guys, they don't like having DBAs on their storage servers. So.
Yeah, but on the other hand, if you're using SAN storage, it's also going over a network. It's also hard to troubleshoot sometimes. So.
Any network attached storage, it applies to every single one of those things rather than direct attached storage, basically.
Yeah, well, at least SAN is probably a little, probably not quite as flaky. You generally have a direct connection, but still, yeah, certainly you don't know what else is using the SAN and all that kind of stuff.
Exactly.
Yep.
And you can compartmentalize it a little bit better, but it's still an issue. You still come across those issues with the SAN as well.
Well, and then you have the issue of the controllers. Different SAN brands have different controllers with different behavior, and sometimes it's difficult also to assess what that is going on.
Yeah,
there.
With all those lovely product matrices with compatible versions and.
Yeah, and anyway.
Out of curiosity, has anyone ever run MySQL on a shared storage volume or SAN that was predominantly solid state, not spinning disk?
No.
I've heard of it in the wild, but I don't have a direct experience myself.
Yeah, I haven't used it myself, but I think it'll probably be more common, I imagine, moving forward, because violin memory and peer storage and a bunch of different companies are making those all-flash storage arrays now, which seem pretty popular. But I would love to, but I haven't been able to actually get my hands on one.
In high traffic situations, the problem is the SSDs, the individual drives. People are not using server quality SSDs because they're extremely expensive. They burn them in a question of months, if not weeks.
Yeah, and so that's definitely something to kind of think about and evaluate. And I think it was more historically shared storage, spinning disk, and like Mark was saying, things could come out of nowhere from other applications that are potentially touching the shared storage, and that would negatively impact your performance. And I mean, and you think about it, like historically with a database management system, disk is almost always the bottleneck that you're fighting with. And that's what's interesting for me is in my environment, I/O is a non-existent problem for us because we're predominantly on solid-state drives, Fusion I/Os to be specific. And that's why this notion of shared storage, I think the shared storage that we're looking at for some of our stuff down the road is a mix of solid-state and spinning, and it's predominantly solid-state to give you a very fresh caching layer almost, I guess, or like a fast write layer that gets archived into the bigger spinning disk storage layer. But it's definitely something that, yeah, historically DBAs, we just run away screaming when we're told we have to use shared storage, at least in the case of like high performance applications. But I'm curious how it's definitely going to change going forward now that solid state's becoming more affordable and being able to kind of mix into these things.
Well, yeah, I think like you were saying, even if you get a more typical SAN, so you've got an array of 2.5-inch 10K SAS drives. Most of them, from what I've seen lately, most of them they'll have an SSD for the write cache. So before you might have had used RAM for 512 or 1 gig write cache, but now you can have it'll use a SSD, so you'll have this non-volatile file system so you can have these huge write caches to go along with your more standard disk array. So I think most people are probably going to be using SSD in one fashion or another in the years to come.
Yeah, so that's definitely something I'd be very interested to see is how shared storage looks like running MySQL on shared storage that's predominantly flash of some sort, and just numbers and kind of common issues that you might encounter. Are they different than the historical issues that are out there?
Well, one of the things when I was benchmarking Fusion IO cards, the guy that really actually was screaming to me was the network administrator, because basically since you're removing the storage, the IO bottleneck, you're pushing all that information through the network. So the network capacity started suffering, and I'm wondering if that won't make it, if you're using NFS with a regular NAS, whether that is how that is gonna play based on the experience that people have had with NFS in general.
That's a really good point. Yeah.
It's one of the other points as well with that. Well, one of the things with 5.6, especially, is you can actually, on a per table basis, set the data directory and the index directory. And one of the things that has just kind of been in my head, but not really seen anybody do it, but I wonder if people will do it in the future, is having things like the less performance critical aspects of their database, because there always is, right? You get logging tables and all of these big ass tables that aren't necessarily the performance critical bit of your app, but there are a lot of space and those kind of things. And I think that in those cases, NFS could be, or some network attached storage could be appropriate for those, whilst you keep your performance critical or critical tables on direct attached storage. Because I mean, there's not just you're sending all the data over the network, right? I mean, there's the extra latency of getting and sending the data over the network and all of those kind of problems that you've got to hit. But if you can split maybe the high overhead but less performance critical bits of your database off to NFS, whilst actually keeping the I/O on your direct attached storage dedicated to the more performance critical bits, then it's a better way to split up your I/O. So that's really what the data directory and index directory enhancements are for, so you can split I/O around, right? And that's one of the use cases that I think should, whatever, be investigated in certain environments. Depends on your schema, right, and how the pattern of access is. But.
Yeah. All right. So we are actually out of time today. So that was it's kind of fresh to hear about shared storage. It's something a lot of folks never have anything good to say about. But it sounds like there's some a little bit of positive coming up. Like Matt had said with NFS v4 and whatnot. But yeah, so maybe we can touch on this a little bit more next time. And also the next time, maybe Matt, you can give a little overview of our indexes, a little more a more complete one, I guess.
Yeah, it would take maybe 10 minutes. I mean,
Okay.
unless people had a bunch of questions, but I think when I explain it well enough, I don't think there'll be too many questions.
Cool. And did you have something to say, Daniel?
Oh, for the positive things about NFS. It's Also, making snapshots is really a good thing about NFS.
Yeah, that makes doing backups and crash recovery very doable.
As a last word on that, favoring smaller databases to run on VMs on NFS actually is a good solution, and leaving the high performance stuff with direct attached storage, or maybe NetApp or something, a solution that it's more sophisticated than just a NAS and an NFS for the high performance ones.
Yep.
I've seen those combinations actually work.
Okay. All right. Well, I think that's a wrap for this week. Thanks very much, everyone who came and participated today, and look forward to seeing the rest of you in 2 weeks. Last two announcements. I think, Matt, you have a webinar coming up sometime next week.
It was yesterday, actually.
Oh, darn. Okay.
Yeah. But they'll be you'll be able to watch it on demand. It should be available maybe either tomorrow or early next week.
Okay, cool. So I could probably grab a link to that. And then the other one is, if you haven't signed up for MySQL Central, you should do that.
Yeah, for sure.
Alrighty. Thanks very much, guys, and we'll see you next time.
All right, thanks, guys.
Later, guys.
Bye.
Thanks. Bye.